Hello guys, I will be doing the physics quiz for this week. Okay, so we have Pascal's law, and let's visualize a container with a liquid, and we have this point. It's called point O, and we have a pressure acting on it. This pressure will not happen on one specific direction. No, it will be acting on every single direction. The pressure exerted by the liquid on this point. Okay, in the liquid. Okay, it's acting in all directions. This feature is called isotropic. Okay, so the fact that at any point the pressure exerts in all directions is called isotropic. Okay, for this question we have a container and we have a glass and we have a straw. Sorry, the container is a glass. We have a straw. Okay, we have to choose if these options are true or false. The pressure in the straw is always equal to the atmospheric pressure. See this keyword always? You see it? خلاص, choose it false, because what will make you say, or do you have any proof that states that the pressure inside of the straw, the pressure that's inside of the straw here, inside of the straw, pressure that's inside, is it equal to the atmospheric pressure? No, there's nothing that states it's the same. Okay, so this is not always equal. It's wrong. The pressure inside the straw is smaller than the pressure outside at the same level. We learned that in a container, we have a liquid. The pressure at this point is equal to the pressure at this point. Reason is because they're at the same horizontal level. So 2 points in a liquid at the same horizontal level, they will have the same pressure being exerted on them. But this is because they're in the same medium. Now we have this point and we have let me choose it another color. We have this point and we have this point. One of them is outside the straw, one of them is in. They're at the same horizontal level, but the thing is they're not gonna have the same pressure exerted on them. Okay, because here we have different suction forces, we have differences in pressure, we have different tension forces. One of them has tension forces. So just memorize that the pressure inside the straw is at the same level. Even if it's at the same level, it's still different than the pressure that's outside of the straw. Even if it's at the same level, we don't care. It's gonna be different only in this case. Okay, and in fact, fun fact, it's not gonna like sorry, it's the pressure that's inside of the straw, it's gonna be smaller. Okay, this is a fun fact. Difference in pressure causes the liquid to be pushed up the straw. This is something biology students know. It's called bulk flow. But if you're not a biology student, you should just know that when there's a suction force, the difference in pressure, so like there's a pressure here, the pressure here, like the differences in pressure all around the straw will cause the liquid to move up. Okay, you see the cursor, it will be moving up the liquid. This is due to the differences in pressure. Now, if we have the container, and if a hole is made in the straw, okay, we have the hole here. We have the hole here. If there's a hole made here, either water will enter or water will leave. Okay, like water will enter or what's inside will leave if there's no container. If you get what I mean, stuff will enter and they will leave. Okay, this will not permit the water to flow up. Okay, due to this interruption that's located in here. So this is correct, since you will not be able to drink. Now the pressure of the liquid inside the straw exceeds the atmospheric pressure. So inside of the straw here, is there any proof that says that it will exceed the atmospheric pressure? The same in the first option. These two options, they have no proofs. There is nothing to support it. Okay, to support these statements. Okay, this one, cross-sectional area of a shoe's heel. We know that pressure is equal to the here's a big P, force over area, which is equal to rho GH. Now, using these givens, we can notice that we can use this rule. It's easier. It's easy. We cannot solve using the other rule. We know that the force is 600, okay, of the human, because the force in this case is equal to the weight, okay? And then we have the area. The area here is not gonna be 150 because 150 is for one shoe, but we have two shoes, so it's gonna be 150 times 2, okay? And 150 times 2 is 300. So then we got 300 centimeters squared. Let's convert this to meters squared by multiplying it by 10 to the negative 4. So 300 times 10 to the negative 4. You put this on the calculator and you will get 20,000. Okay? Put it in the calculator, you will get 20,000. Because why do I do 10 to the negative 4? Because from centimeters squared to meters squared, you multiply by 10 to the negative 4. And from meter squared to centimeter squared, you multiply by 10 to the 4. Okay, and they want it in scientific notation, so 1, 2, 3, 4. Okay, we have, we know that pressure is equal to force over area, which is equal to rho GH. We have mass, we have density, we have height, and we have G. We can notice that we can easily use this rule, but we notice that we have mass, and since force is equal to the weight, and weight is equal to mg, we have G and we have m, we can find the force. So 70 times 10, you will get 700. But the thing is, the reason we don't use this rule is because we do not have the area. So this rule is useless. We use this rule. Density times G times H, which is 1020 times 10 times 5. Plug this into the calculator. You will get 51,000. And 51,000 in kilopascals is 51. Okay, remember, you remove the last 3 zeros since 1 kilopascal is 1,000 pascals. Okay, we have a small object immersed in a liquid of density 1000. It's 2 meters below, and density of this liquid is 1000. Okay, and we know that G is 10. Okay, and the atmospheric pressure is 100 kilopascals, and in pascals it's 100,000 pascals. Okay, so the total pressure, it's gonna be the pressure of the liquid on the object plus the atmospheric pressure. Why do we do plus atmospheric pressure? This is an open-end container, so we're not only gonna have the pressure exerted on the liquid on the object, we're gonna have the atmospheric pressure too. So we add both of these pressures. Okay, so firstly we can find the pressure of the liquid using rho GH. Rho is 1000, or density, times G, which is 10, times H, which is 2. Okay, and you plug this into the calculator, you get 20,000. Okay, 20,000 what? 20,000 pascals. You add it to 100,000, so 100,000 plus 20,000 is equal to 120,000 pascals, or in kilopascals, what is it gonna be? It becomes 120 kilopascals. Okay, here we have two scenarios where the container is open end and when the container is closed end. When the container is open end, take in mind that closed end, that means it's just going to be the pressure of the liquid on the object, or the pressure of the mercury in this case. Okay, but if it's open end, take note that we have pressure of the atmosphere, or known as atmospheric pressure. Let's do the closed end, and by doing the closed end we can easily find the open end. You know the rule, pressure is equal to rho GH. Rho is 13,600 times G, which is 10, times H, which is 12 centimeters, but we want it in meters since the rule is used in meters, which is 0.12 meters, because 12 centimeters is 0.12 meters. Plug this into the calculator and you will get 16,000 pascals, but they asked for kilopascals, so remove the last 3 zeros. So, okay. Now they said open end. The total pressure is equal to the pressure of the mercury plus atmospheric pressure. Pressure of the mercury is what? 16,000 plus atmospheric pressure is 100,000. So 16,000 plus 100,000 is 116,000 pascals. But they want it in kilopascals, so it becomes 116 kilopascals. We have this hydraulic press. We have two different locations where the force is being exerted, or the pressure. It's on these places, but we can notice that they're on the same horizontal level. This means that the pressure exerted on here, it's going to be the same as the pressure exerted on here. So the pressure on point A, let's call this point A and this point B. The pressure exerted on point A is equal to the pressure exerted on point B. Okay. Pressure has two rules, F over A and rho GH. Obviously for this one, we have the givens for this one. We have no density, we have no height. So we do pressure is equal to FA. Let's do for this one. What's the force? They gave us 20. And the area is 4 centimeter squared. Okay? 4 centimeters squared, I mean. We want it in meters squared, so we do 4 times 10 to the negative 4. Plug this into the calculator and you will get 50,000. So you will get 50,000 pascals. Okay? And now we can finally find the upward force for this one, which is what we're trying to find. And since they're the same pressure, we can just use the same pressure. So 50,000 pascals is equal to the force over the area, which is 50 centimeters squared. Let's convert 50 centimeters squared to meters squared by multiplying by 10 to the negative 4. So if we plug this into the calculator and we cross multiply, we do 50 times 10 to the negative 4 times 50,000. Plug this into the calculator, you will get 250. Okay. Now, for this one, it's a bit more complicated. We have more information and we have more stuff. So we have 10 tires in a truck, and every single tire exerts this force or this pressure. And every single tire has this area. So a technique we can do is calculate the pressure, or we can calculate the pressure or the force, the force exerted by one tire, and then we multiply that force by 10, since we have 10 total tires. So let's see. They gave us pressure, they gave us area. We need to find the force, not find the force, what we need to find is the mass. But the mass is given by F, which is equal to the weight, which is equal to the mass times G. So we need to find the force, and when we find the force, we can find the mass. So we can use the rule, pressure is equal to the force over the area. Now let's calculate the pressure of one tire. The force exerted, we'll keep it as F. The area of one tire is 400 centimeter squared, but times 10 to the negative 4, right? Because we need to convert to meters squared. And the pressure by one tire is 200 kilopascals, or 200,000 pascals. So we cross multiply, we do 200,000 pascals times 400 times 10 to the negative 4. And then you plug it into the calculator and you will get 8,000 newtons for the force. This is exerted by one tire. Now, by 10 tires, we just multiplied by 10. And you will get 80,000 newtons by 10 tires. now that you found the force, and since force is equal to weight, which is equal to mg, and g is 10, and the force is 80,000, we can divide by 10 on both sides, okay? And we get that the mass is 8,000 kg. And here they gave us tons. You should know that 1 kg, that 1 ton, I mean, is 1,000 kg. Therefore, 8,000 kg is 8 tons. Okay, you have this diver in a horizontal direction, you have height, you have density, and you have G. Pressure is equal to rho GH, so 1000 times G, which is 10, times H, which is 5. So you just plug it into the calculator and you will get 50,000 pascals or 50 kilopascals. Okay. An open-end manometer measures the difference between the pressure due to a liquid or gas and the atmospheric pressure. Okay. So an open-end manometer does not only measure the pressure due to a liquid or a gas, but it also measures the atmospheric pressure, since the total pressure in an open end is equal to the pressure of the liquid slash gas plus the atmospheric pressure. Okay, this must be memorized, the difference between the pressure due to a liquid or gas and the atmospheric pressure. Okay, usually this is the sum, okay, but here they're telling us the variation in these two pressures. Okay, now for this question, we have this container, we have a liquid, and we have the coin here. It's horizontally down. We have the center C, and it's at the depth H, and we have pressure P. Okay, what we know about pressure is that it's isotropic, which means it's acting in all directions. But they're asking for one specific direction of the force exerted on the upper side of the coin. What we know about pressure is that it's perpendicular to a surface. Therefore, it's gonna be perpendicular to the surface. So it needs to be like this to be perpendicular. What is this? It's vertical down. So vertically downwards. As we just discussed now, the force exerted due to the pressure of a fluid in the container is normal or perpendicular to its surface. Pressure is a scalar quantity and it's equal to the force per unit area. Per unit means divided. Okay. Manometers, or like YouTube manometers, measure pressure. Like memorizing these few questions that were previous now were to be memorized. Okay, we have a human body can withstand a maximum of 1.8 times 10 to the power 5 pascals of pressure due to water. If the density of salt water is this, and the acceleration of gravity is 9.8, then the maximum safe depth at a human can dive to one decimal place is this. So pressure is equal to rho GH. Okay? Rho being density, which is 1.03 times 10 to the power of 3, or, okay, times G, which is 9.8, times the height, which you need to find, and the pressure they gave it to you is 180,000, or 1.8 times 10 to the power of 5. Okay, you plug it into the calculator, you divide like this by this, times 9.8, divide by 1030 times 9.8. Okay, plug this into the calculator and you will get to 1 decimal place. Okay, you will get it to like many decimals, but 1 decimal place, round it up, you will get 17.8 meters. If a liquid is open to the atmosphere, its surface will be acted upon by what is known as the atmospheric pressure. Okay, we'll have the atmospheric pressure. Describing atmospheric pressure are true. Atmospheric pressure is never constant. Okay, it can change due to some variations and limiting factors. Difference in pressure causes winds to blow and rain to flow. You should memorize this because in some areas you have more pressure than the other, or like the differences in the pressure. Okay, in some areas it will cause the wind to blow and it might cause the rain to flow. That rhymes. So difference in pressure causes wind to blow and rain to flow. Atmospheric pressure is affected by weather conditions, yes, due to climatic stuff, weather. These factors can change the atmospheric pressure. Here it's false because the changes in pressure do affect the atmospheric pressure. Changes in pressure, they do affect the pressure. Okay, consider the closed-end manometer. Okay, we know that pressure is equal to rho g h. What do we have rho as? We have 1.36 times 10 to the power of 4, or 13600, times g, which is 10, times the height. Here they gave us two heights. They gave us height 2 and height 1. Now, here they gave us a figure. We need to find out what is the height we need. In pressure, this is the height we need. This height here. To calculate it, you should memorize it. If you don't understand it by now, or you cannot understand it, you should memorize that this is the height that we deal with. Okay? So basically it's H2 minus H1, and H2 is 60 and H1 is 12, and 60 minus 12 is 48 centimeters. Let's convert it to meters. We get 0.48. So times 0.48. Plug this into the calculator. You will get 652 and a bunch of numbers, okay? And then 6520, approximately this number. Actually, you will get 652 and then numbers, okay? But you need it to be in kilopascals, okay? So you get rid of these numbers here. So you get like rid of the last three numbers, including the 2, so it becomes 65.2, and they want it in 1 decimal place. Okay, so just plug this into the calculator and you will get 65.2 kilopascals. Okay, now for this question, we have this manometer and it's open end. We can see that there's an opening here. Therefore, the total pressure will be equal to the pressure of the liquid plus the atmospheric pressure. Okay. They said the mercury level in the arm of the manometer connected to the gas is lower than the other end by 76. So the mercury level in the arm of the manometer, this is the arm of the manometer, it's slower than the other arm, which is this arm, by a factor of 76. So this is lower by 76. Therefore, this is 76. H2 minus H1 is equal to 76. I will repeat it again. This is lower than this by 76. Here it says that it's lower by 76. The question is hard to understand. Master a way to understand and interpret the question, and then you will finally get it. This arm, or the H1, is lower than H2 by 76 millimeters. So this is 76 millimeters. And you have the atmospheric pressure, which is 76. Didn't we say that, okay, this is the height, 76. It's technically 76 millimeter mercury. Okay, since this is the height, خلاص, this is the pressure. 76 millimeter mercury, right? So we found the pressure plus the atmospheric pressure, 760. So you do 76, which is the pressure of the liquid, because you found this pressure here. This is the pressure of the liquid. This thing here, this section, it's the pressure of the liquid, because you found the height. And isn't the readings of the manometer the pressure measurement? Yeah, it is. So this is 76 and the atmospheric pressure is 760. So 76 plus 760 is 836. This needs time to understand. Rewatch this clip to understand. Rewatch the part to understand it. Now for this question, pressure is equal to the force over the area. Okay? The force is mg, and you have the mass, which is 80 times g, which is 10. So 80 times 10 is 800, divided by the area of the shoes. It's 200 centimeters squared. Convert to meters squared by converting to meters squared, it's 200 times 10 to the negative 4. And 800 divided by 200 times 10 to the negative 4, it's 40,000, or 4 times 10 to the 4 Pascal. Okay, for this question, pressure is measured using a pressure gauge and liquid pressure is measured using a U-tube manometer. Okay, for this one, a force of 5 newtons, we have the length of syringe is 3, although it's most probably not needed, this information, and we have the area of the syringe. Pressure is equal to the force over the area. The force exerted on the syringe is 5. The area is 2 centimeters squared. We want it to be in meters squared by multiplying by 10 to the negative 4. The answer we get is 25,000. 25,000 pascals. Convert to kilopascals, you will get 25. Now, pressure at point B. We can notice that point A and point B are at the same horizontal level. Therefore, the pressure at point A is the same as the pressure at point B. So if it's at point A, it's 25,000. At point B, it's also going to be 25,000 pascals or 25 kilopascals. Okay, crush depth is the maximum depth a submarine can submerge without getting damaged. Crush depth of a Sea Wolf class submarine is about 730. We have density and we have G. Okay, pressure is equal to rho GH. You have rho, it's 1020 times G, which is 10, times H, which is 730. And then you multiply these together and you will get 7,440,000. Okay, 7,440,000 pascals, okay? You multiply these three together and you will get this. They asked for M pascals. K pascals, okay, it's 1,000 pascals. M pascals, it's gonna be 1 million. Okay? So basically it's 7.44. Because I want 3 sig fig, so 2 decimal places. Okay, 7.44. This is to be memorized. It's a function where we can, it's an application of pressure. And when a plunger sticks to the surface, it's because of the atmospheric pressure. Since the pressure on the outside, which is atmospheric pressure, it's lower than it's greater than the pressure that's on the inside. So the pressure that's inside here of this plunger, it's smaller than the pressure here on the outside. The fluid is open to an atmosphere. The surface will act upon by what is known as the atmospheric pressure. Okay, here we have two tubes. And they're at the same height. Okay, this has a radius 1 and this has a radius 2, as mentioned here. Okay. On vacuum 1, it will raise to 800 millimeters. In vacuum 2, what do you think it will raise? There's the same pressure, the same density, same gravitational acceleration, same everything. This means it will also raise to the same height. It doesn't matter the radius, because using the rule, the radius is not a limiting factor. It's only these 3 or these 4 that limit this stuff, okay? So the height will stay the same because they're at the same level and there's the same pressure. So because it's the same pressure and the same density, I guess, then I guess it will be the same height. Okay, rank the following setups according to pressure. Note that some of them are opened and some of them are closed. The label setup with the highest pressure, number 1. So the one with the highest pressure is number 1. The height of each vessel, maximum, is 30. Okay. We know that the pressure total is equal to the pressure of the liquid plus atmospheric pressure. Therefore, the ones with atmospheric pressure, they're the ones with the greatest pressure. So, what can we choose as the first one? The one with the highest, the one with the liquid when it's the highest point, and it's the one that's open. So, we can see E, C, and B. E, C, and B are the 3 highest out of the 6. Now, out of the 3, which one is the highest? E, definitely not. C, definitely not. We can notice which one is higher, C or B. C is the highest one, since it's opened and it's the highest one here. Now, B goes second, since it's open here and it's the medium highest. And E, it's open, but it's a bit low here. So E is the third one. Now we can go to the ones that are closed. Actually, they're not 6, they're 5 total. Now we go to the ones that are closed, which are only 2. We choose the one that is the highest one out of the 2, which is D. Look at it, it's very high. So we choose it as 4, and A is the lowest one, that is the closed one. What we can notice about D, that it's the highest one out of all of them. So you will ask yourself, why did we not choose it as 1? Because it's closed here. So the only pressure that's acting upon it is the pressure of the liquid itself. If it's open, it would have been the highest one, since there would have been atmospheric pressure acting on it. Okay, consider a closed end manometer. Liquid in the tube, mercury of a density 13.6 grams per centimeter cubed, and we have H1 is 15 and H2 we need to find it. They gave us a total pressure and G. The pressure of this system is this one, the height, it's this what we're gonna use. It's this millimeter, it's this one, okay? Basically it's height 2 minus height 1. So let's formulate the rule. Pressure is equal to rho GH. What is the pressure that they gave us? It's 30,000 pascals is equal to rho. We're going to keep it aside because we can notice that they have the wrong measurements, okay? Rho times G, which is 10, times H, which is H2 minus H1. What is H1? It's 15, but it's 15 centimeters. We want it to be in meters. It becomes 0.15. So 0.15. Okay, now we have density. Density, we have it in grams over centimeter cubed. Let's do the conversion factors to convert the 13 grams per centimeter cubed to kilograms per meter cubed, because the rule will not work without doing this conversion. Remember conversion factors? Okay, let's convert grams to kilograms. We put grams in the denominator because we want to destroy or cancel the units. So 1000 grams is 1 kg times centimeter cubed. So 1 meter cubed is how many centimeter cubed? It's a lot. It's like 1 0 0 0 0 0 0. It's 1 million. Yeah, it's 1 million centimeter cubed is 1 meter cubed. Now we can cancel these units here. Cancel these units. And we can cancel the zeros. So we can get that 1 3 6 1 and then 2 3 2 3 0 0. So 13,600 kilograms over meters cubed. Sorry, there's a noise of the cars outside, if you heard it. So this is the answer. This is the density. 13,600 times 10. Okay, let me copy it down. So 30,000 is equal to 13,600 times 10 time okay, it went. I think you can barely see like this. Okay, so times 10 times H2 minus H1. We need to plug it into the calculator. Oh, it just went. Wait, let me get STP back in. Okay, so I'll rewrite the rule. 30,000 is equal to 13,600 times 10 times H2 minus 0.15. So you multiply these two together, you get 136,000 divided 136. Okay, plug it into the calculator, is equal to H2 minus 0.15. Okay, and then you find H2. You'll find H2 to be put it in the calculator, and when you put it in the calculator, when you're done doing this division, you move 0.15 to the other side, and when you're done in the calculator, you will get 0.3705, something like this, approximately this number. But they got it in meters, you want it in centimeters, so you move two places, so you got 37. The only confusing thing in this question is the conversion factor of density and the H2 minus H1 part, since we want to find this height. Since this is the height we're working with, we do H2 minus H1. So this minus this, and you find this. And the last and final question. Okay. When the rubber head of the hydrometer is squeezed, the pressure of air inside the tube is lower than the atmospheric pressure. Just memorize that when this top is squeezed, the pressure of air that is inside of the tube, it's gonna be lower than the atmospheric pressure that's outside. Just memorize this. Okay. Now, pressure is equal to rho GH. Okay? So rho is 1,200 times G, which is 10, times H, which is 15 centimeters. How many meters is that? 0.15 meters. Okay? Do it in the calculator. You will get 1,800. But they want it to be in kilopascals, so you get 1.8 kilopascals. That's it. That's the end of the video. Good luck in your exam and goodbye.